Welcome to our tutorial on Storm's geospatial features. Today, we'll show you how to import real-world height data into Storm with just a few clicks. You'll also learn how to texture these terrains with Gaia and apply storm vegetation. Before we get started with the tutorial, please notice that Storm comes with a lot of offline information that might help you if you're stuck. You can find the Storm user guide and additional documents in the Procedural Worlds folder of your installation. Also, most of Storm's user interface features a question mark icon that allows you to view help texts that explain the functionality of each element on the screen. Likewise, you can also hover the mouse over entries to see a help text popping up. But let's get into the video now. To follow along with this video, you will need an HDRP project with Storm installed. For texturing with Gaia, you would need to install Gaia. If you want to test vegetation spawning with Storm, you can optionally also install the Book of the Dead Biome package, which you can find in your Storm downloads. Storm allows you to directly import and work with external data in the GeoTiff format, a standard in GIS applications. While commercial providers offer high-end GeoTiff downloads, free data is often available through government agencies like the USGS. To simplify this process, we've created a discovery and download service for freely available data. Currently, we have integrated the USGS National Map, OpenTopograhy, EOX Sentinel-2. Please note that our service is only for convenient search and discovery of the data, but the actual data is still downloaded directly from the original providers. Please make sure that you stay within the terms of service of those providers when you use their data. You can find links to the terms of service in the video description. You can access our service under maps.procedural-worlds.com. On your first visit, you'll be asked to enter API keys. A Google Maps API key is required to display the world map to browse and select data. You can get such a key from Google Maps by following the link in the instructions. The OpenTopograhy API key is optional, but grants access to additional height-map data. For step-by-step instructions, please check the Setup Guide link at the bottom of the input box. Once your keys are set, the interface functions similarly to Google Maps. You can switch between satellite imagery and a relief view to see the terrain shape better. It is also possible to look at Street View images to get a perspective from the ground. Last, but not least, you can enter common landmark names into the search bar on the top. To select your data area, set your desired region size. There is no upper limit in theory, but the bigger the region size, the more data will need to be downloaded and processed. We tested the system for imports up to 20 by 20 kilometers. Click Select Region and click the map to place your selection box. Adjust the size and position until you're satisfied, then click Search. The system will display found data in a new window. Hover over any entry to see its coverage area. Note that while some data matches your region perfectly, others are provided in tiles. If your region overlaps multiple tiles, Storm will automatically tailor them into your selected area during import. If the exact region selection is not important to you, you can save on download size and processing time by aligning your region so that it sits within a single data tile. Another important factor is the resolution of the datasets, which can be found in the technical information in the listing. A value of 1 meter means that there is 1 data point per square meter of the terrain that was measured. So the smaller this number is, the higher the resolution of the data. Different data sources have different resolutions for their captures. You will usually want to get the highest resolution, which will lead to the best quality for your imported terrains. The USA has great coverage at 1 meter resolution, thanks to the data provided by the USGS. The rest of the world has data at 30-meter resolution from the OpenTopograhy datasets. You can pick which types of data and which datasets you want to download with the checkbox on each entry. Once you have selected the datasets, you can click the Download button to initiate a download to your PC. Please note that the files are directly downloaded from the original sources within your browser. Procedural Worlds does not host these data files themselves. If the original source is not available, this may affect the search results and the availability of the downloads. You can extract the zip file from your download into a folder of your choice. In the files, you can find the GeoTiffs and the satellite images, but also some metadata. In the datasummary.json file, you can find meta information about the files in JSON format. The boundary KML file is information about the area that was selected on the map in KML format. You can build your own integrations for your systems to get geodata into Unity and Storm if you can output data in the GeoTiff format and add the matching metadata files for it. Whether you use our map portal or another source, the import process within Unity is the same. Open the Storm Manager. Select the Storm Plugins tab. Open the Geospatial panel and select the Import tab. Then browse to the directory containing your GeoTiffs. Storm will automatically populate the panels with metadata regarding the location and scale of your data. In the Import Settings panel, you can configure the generated terrains. Pay close attention to the Apply Imagery setting. This determines if satellite images will be used as the primary terrain textures. Click Import Terrain to begin. Within minutes, Storm will create a tiled grid of Unity terrains, representing your real-world data. These are standard Unity terrains, meaning you can continue to refine them manually or use tools like Gaia and Storm to further enhance them. If you have the option selected to apply satellite imagery, the import will split up the satellite image automatically and apply them to the first layer of each created terrain tile. The resolution from the freely available EOX Sentinel data is relatively low. You will get better results with high-resolution imagery from paid data providers. If you are interested in creating an integration for another mapping provider as part of your project, please get in touch with us so we can suggest possible solutions. To convert these terrains into a Gaia setup, open the Gaia Manager and go to the Create World tab. Gaia will detect the existing terrains and suggest ingesting them at their current size and position. If you want to use terrain streaming, check the box for creating terrain scenes. Gaia will then put each terrain tile into a separate Unity scene that can be loaded on demand. You can also select a biome that you want to add into this scene. Make sure the ingestion workflow is selected, and then click the Ingest or Update Terrains button. Once the process is complete, Gaia manages these terrains as if they were created within the tool. You can now run individual spawners or the entire biome. For this example, we'll run texture spawners only, then return to Storm for vegetation. Now that we have textured terrains, we can add vegetation with Storm. In the Storm Manager, go to the Ingestion tab and ingest your terrains. Please check out our dedicated tutorial on spawning and ingestion if you need more information on this step. Once finished, create a global region to spawn one of Storm's ready-made biomes, or you can start a custom biome with a new feature set. After tweaking the lighting and the Storm vegetation a bit, this is the final result we got out of the geodata for our selected region. Creating this scene took only minutes. Normally, you would be looking at days or weeks if this was done with a manual workflow. Storm can also spawn vegetation based directly on the satellite imagery from your data. This is ideal for digital twinning or simulations where realistic imagery is preferred over game-like texturing. To do this, ingest your terrains into Storm with the satellite images applied. Please note the input field for the default color targets file selection. If a color targets file is assigned here, Storm automatically sets up color selection data for terrains that use a single texture layer only. This is the case in our scene, where we only have the satellite images on the terrain. We will take another look at the color targets file later, but for now, we will use the default file that comes with Storm. After ingesting, inspect a Storm tile. You'll see texture color selections which are based on the default color targets file. These color selections map specific colors in the satellite image, like the green colors of a forest, to Storm layers for spawning. You can adjust the color range and falloff to fine-tune the selection. Scroll to the Preview tool at the bottom of the list. Click Preview to see the satellite texture. Select a list entry and click Overlay to see exactly what data Storm is selecting. You can adjust the color, the range, and the falloff, and see in the preview what parts of the source texture would be selected this way. In this example, we're spawning trees on the green tones of the texture. Those colors generate data for the PW trees layer, which the Storm feature sets then use to place objects. When we then assign a region with such a feature set to the Storm world, the vegetation begins to spawn in the right spots. Finally, we can now take a look at the mysterious default color targets file that we used in the ingestion process. This file works like a template that you can use to assign certain color selection settings during the ingestion process. You can create your own color targets file from the Create menu in the project hierarchy. In there, you can maintain a list of color selections that you map to certain Storm layers for spawning. If you use your custom file in the ingestion process, the color selections stored in there will be applied in the resulting Storm tiles. That concludes our look at Storm's geospatial features. By combining real-world height data, Gaia texturing, and Storm vegetation, you can create massive, stunning worlds in record time. Thanks for watching, and we'll see you in the next video.